What we're going to do is we're going to take what we did on Tuesday and now incorporate domain. So your homework tonight on that packet that you got on Monday, you're actually never going to answer range. We're just going to concentrate on domain. What can we plug into the function? What x's are available? So let's talk about this definition. Domain is any input or x value that makes a real output, y value, when substituted into the function. So for these rational functions, this is every x value except the number of the vertical asymptote. What we're going to do is graph each function and then state the domain. So you've got this first function. Let's go through the pieces that create a rational function without making an XYT chart. First thing up is how to find the zeros. When we found the zeros, we set the equation equal to 0. So multiply both sides by the denominator. So on the left side, we get 0. And on the right side, the denominator undoes, or multiplying by 3x minus 15 undoes the dividing by 3x minus 15. So we're left with 0 equal to the numerator, 4x plus 1. So we're left with negative 1/4. That means we get the x-intercept, negative 1/4, 0, which creates a point at negative 1/4, 0. So then next step. After we find the 0, we're going to find the vertical asymptote. Vertical asymptote is when the function is undefined. So what will make that denominator equal to 0? So we set up an equation. What makes 3x minus 15 equal to 0? Because that's going to create the vertical line I can't cross. After you solve, so add 15, divide by 3, we get a vertical asymptote of x equals 5, and we're going to immediately put a dashed line in, representing that this dashed line is only helpful for us to graph, but technically it's not part of the graph. So the last piece, horizontal asymptote. When we're trying to find the horizontal asymptote, this is when we have to look at the degrees. You go back to the function and you look for the degrees. So the degrees of the numerator polynomial and the denominator polynomial are 1s. Because they're the same, that's when, wait a second, if the numerator degree is the same as the denominator degree, that's when we're going to look at the leading coefficients, 4 and 3. So the leading coefficients become our horizontal asymptote, y equals 4/3. That's where that horizontal line came from. 4/3 is about 1 1/3. It isn't about, it is. We know this is going to create a simple hyperbola. So bottom branch will get close to the horizontal asymptote but never cross, and then get close to the vertical asymptote but never cross. And the other branch is somewhere similarly up here. So now we're going to include domain. What can we plug into this function? If I were to do a huge t-chart, which one will give me the undefined answer? So what we're going to say is domain, I can plug anything in. That's what that symbolism is saying. X belongs to the real numbers, the set of real numbers. I can plug anything in. I could plug pi in. It's going to give me an ugly answer, but I could still plug it in. But I cannot plug in 5. So next example. Let's immediately plot the 0. So at the vertical asymptote, you're zooming in on just the denominator. What would make that denominator 0? So we get 2 vertical asymptotes, 6 and negative 1. Let's do 2 vertical lines that are dashed through both of those numbers. My bad. So positive 6, negative 1, negative 6, positive 1. Still vertical lines at those numbers. So the horizontal asymptote, you got to look at the degrees. Bottom degree is bigger than the numerator, so horizontal asymptotes y equals 0. We're going to do a dashed horizontal line. this is still going to have a hyperbolic shape, just like what we've had before. Those two branches still are going to be on our most extreme left and our most extreme right. So when we get this problem, we're still going to have the hyperbolic shape on the extremes. Strategy: you plug a number in to the left of your x-intercept, you plug a number in to the right of your x-intercept. So I get positive 1/3, -3, positive 1/3. And then if I plug in -1, for example, I get -2/5, which is down here. So we're looking cubic, getting really close to the vertical asymptote, getting really close to the other vertical asymptote. So the most difficult about this is the middle. The branches on the extremes still stay the same. We're still going to have a hyperbolic shape, but now in the middle, we're going to actually have to plug in only two numbers, one on each side of a possible x-intercept to see, are we looking cubic or are we looking parabolic in the middle? Let's go. Oh, wait a second. We got to do the domain. Domain here is not so bad. We're going to use the same notation as before. X belongs to the real numbers, except I can't be equal to, we would not be able to plug in -6 and 1. This one looks simple. We don't know if it is. We got to start, find the zeros, find the vertical asymptote, find the horizontal asymptote. If you multiply both sides by x squared, you get 0 equals -2. Bad thing is, 0 should never equal -2. This is an example of no x-intercept. You zoom in on the denominator. What would make this undefined? So if you set x squared equal to 0, take the square root of both sides.
Wouldn't it be negative x squared?
I could put the negative with the x squared. Either way, I would divide by a negative, which still gives the 0 to the other, still makes it 0. Take the square root on both sides. Square root of 0 is 0. And if you include a plus or minus 0 is still 0. So the vertical asymptote is at 0. Horizontal asymptote, you look at the degrees. So wait a second. Degree up top is nothing, and we've got a degree on bottom of a 2. So because the denominator's degree is bigger, horizontal asymptote is at 0. We would want to say this is going to look like a normal hyperbola. Bad thing is we have a leading coefficient of a negative. Typically, if you're and when I say leading coefficient, if this coefficient -2, if it's negative, that means the hyperbola is going to be switched. Instead of the branch to the left being down, the branch to the left is going to be up. Instead of the branch to the right being up, the branch to the right will be down. And that's all because of the negative leading coefficient. So domain, all real numbers except 0. Uno más. I'm going to hit pause on this problem because I'm going to complete the video. So we get two x-intercepts, -5, 0, 4, 0. For our vertical asymptote, we're going to set the denominator equal to 0 and solve, either by difference of squares or square root method. Horizontal asymptote, we look at the degrees. They match. So y is going to equal the leading coefficients, which are 1s. So horizontal asymptote is at 1. So the hyperbola, the branches have to go through this x-axis on both extremes. And in the middle, because we don't have another x-intercept, that means it's got to be parabolic here. Just to verify, the y-intercept would be -20 divided by -4. It would be these constants divided by each other, which is a +5. So it is intersecting at +5. My graph is not to scale. I just realized the previous example, I actually graphed wrong. the branches should both be up. I will cover why tomorrow in class. Lastly, domain though, for the last example, which again I forgot, is supposed to be any number except +2 and -2. So x belongs to the real numbers except positive and -2.